What's up, Math 8? Today we are going to be doing lesson 5.6, which starts on page 423. Okay, and this is just over using the Pythagorean theorem. So last class we talked entirely about the Pythagorean theorem. The Pythagorean theorem itself, the formula, how to use it. Okay, as a reminder, the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are going to be your legs, okay, and c is going to be your hypotenuse, okay. Remember, the hypotenuse is the side that is opposite from the right angle, and it is also the side that is going to be the longest. Okay, so if you needed to refresh yourself and write it down, there it is. That's pretty much everything you need to know for the most part here. Okay, so we're going to go ahead and get into today's stuff right now. Okay, so on page 424, we just start seeing some examples. Okay, now you're going to notice these are pretty much all word problems, but the reason is they're actually problems that you would need for real life. Okay, so if we look at number 1, it says write an equation that can be used to find the length of the ladder, then solve round to the nearest tenth. Okay, so the distance from the bottom of the ladder down here, and I'll zoom in a bit, to the edge of the building is 8.75 feet. Okay, and then from this point down here at the bottom of the building up to the top of the ladder is 18 feet. Okay, what we don't know is how long the distance between these 2 points is. Okay, so we can use the Pythagorean theorem to figure that out. All right, so reminder, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, now I can plug in for a and b. We talked last class that it doesn't matter which of those two numbers we put for a, which one we put for b. So I'm just going to go ahead and put 18 for a, and then for b I'll put the 8.75. Okay, and there's our equation right there. Okay, my next step is just to simplify both of those for 8.75 and 18 squared. I don't know those, which is why I'm looking at what the book has. We've got 324 plus 76.5625 equals c squared. Okay, now I will add those two together, which will give me 5625, making sure I wrote that down right, equals c squared. And then lastly, find the square root of both sides in order to isolate the variable c. Okay, and when I do that, I'm going to get about 20. Yep, and that's what they've got too. It's just, that's about 20. Okay, so I'm going to rewrite that. There we go. So c is about 20. So it is about 20 feet. Okay, that is the length of the ladder there. All right, and that's how you do those with word problems. All right, so you can see if we don't know how long the ladder is, that's one way we can figure it out. Things like that, right? So these are problems you'll see a lot. These are the kinds of problems that you can use the Pythagorean theorem on in the real world. Okay, now we'll go ahead and move on to problem number 2. So it says write an equation that can be used to find the height of the plane and then solve round to the nearest tenth. Okay, so if we look at this triangle, we have these two sides. We don't have this side. They label it B. Okay, so that means with our Pythagorean theorem, we know B is going to stay the same. We won't be able to do anything with it off the start. Okay, but then we need to figure out which side is A, which side is C. Okay, I know that the hypotenuse is the side that is opposite from the right angle, which is right here. Okay, so I'm going to go opposite of that, and that side is going to be my hypotenuse, which means it has to be C. So there we have 12 squared. That leaves 10 to be A. Don't forget to square it. Okay, now we just simplify just like any other problem that we've done with the Pythagorean theorem. Okay, so 10 squared is 100. We can't do anything with B squared. And then 12 squared is 144. Next, we subtract 100 from both sides in order to isolate the variable. We're left with B squared equals 44. Take the square root of both sides. And now we're, again, just getting an approximation. 44, if I take the square root of that, that's going to give me approximately 7, because 7 squared is 49, and that's the closest we can get to 44 with a perfect square. Okay, so the side length of B is about 7, which tells us that the, what was the question? It said, can be used to find the height of the plane. So the height of the plane, therefore, must be about 7 miles. Okay, so it's about 7 miles from the ground. All right, and that is how we would do that problem. Okay, so again, these aren't really anything new. All it is plugging in the numbers, looking at the diagram or the drawing that they give us. Okay, and figuring out where everything needs to go in context of the Pythagorean theorem. Other than that, it's all just the same stuff that we did in the last lesson. All right, so on page 425, I want you to go ahead and try out Got It problem A. And just as a hint, your answer should be a whole number. Okay. So if you don't get a whole number, that means you've made a mistake. So go ahead and try that one out on your own, and then we'll keep going after that. All right, so once you've done that, the next thing we're doing is down here, also on page 425, is example 3. It's just another example for us to look at. Okay, you're going to notice now with this triangle, they labeled the angles instead of the sides. So we have this angle is A, the angle up here is C, the angle down here is B. Okay, so that means we need to figure out which side is opposite of the right angle. Okay, so our right angle is down here. Okay, that means the opposite side is going to be up here, which would be this one right here. So that red side that I just drew on there, that's going to be our hypotenuse for this problem. Okay, so that means if the hypotenuse is side BC, we don't need the parentheses. I'm going to rewrite that, sorry. So we have BC squared, and then we've also got the other two sides. So we've got AC and AB, okay? Don't forget to square those sides as well. And now it's just the normal Pythagorean theorem, right? This is nothing different. I know it looks different. It's not any different, okay? So for side AB, we have 7 feet. So I'm going to go ahead and plug in 7 for AB. For AC, we have 12 feet. I'm going to go ahead and plug in the 12. And then for BC, that's the one we don't know. So I'm going to leave it as BC. Okay. Now, we're trying to find the length of a wire, or the length that we would need for a wire in order to stabilize this pole, which you can see kind of makes up this side here, CA or AC. Okay. I'm going to erase that again. But yeah, that's what we're trying to find, is the length of this wire that we would need in order to stabilize the pole. So we'll keep going there. But I know I didn't point that out earlier in the video, so I just wanted to show you that that was what we're trying to find here. All right, so now I'm just going to simplify everything. 7 squared, I should have that memorized. as 49. Okay, 12 squared, I should have that memorized as 144. And then we have BC squared. Okay, next I'm going to add these two together. So 49 plus 144 should give me 193. I believe that is correct. If not, sorry. But I think that's what it is. Okay, and then equals BC squared. Lastly, we got to get rid of the square root just like we do any other time we use the Pythagorean theorem. That will give us BC equals the square root of 193. We're going to estimate that. Okay. 193 is really close to the perfect square of 196, which would be the square root of, which would be the perfect square of 14. So the length BC is going to be approximately 14 feet. Okay. So about 14 feet is the length that we need for the wire in order to stabilize this flagpole. All right. They put 13.9. 14 is good enough for me. So that is it for that problem, and that is also it for this notes video. So you just had the one got it problem to try out on your own. So hopefully that was enough. If not, that's okay. We're going to look at these in class, and you'll get more examples to do both in class and on your assignment. So yeah, that is it. I hope this video wasn't too bad. And yeah, I will see you guys in class.